Question 1. Shortbread biscuits are made from flour, butter and sugar. Their masses are in the ratio 4:3:2 respectively. Part A. What fraction of a shortbread biscuit is made up of sugar? So first of all, I'm going to write that ratio out so I know which section is flour, which section is butter, which section is sugar. So flour, butter, sugar in the order that they're written. 4, 3, 2. So for part A, we want what fraction of the shortbread biscuit is made up of sugar. So our fraction on the denominator on the bottom, that's going to be the total parts in the ratio. So we have 4 plus 3 plus 2. Calculator paper, we don't need to struggle with anything or overload our brain. 4 plus 3 plus 2 is 9. So there are 9 parts in total in this ratio. We are particularly interested in sugar. Now that we've labelled the ratio, we know that that part of the ratio is sugar. So 2 of those 9 parts are sugar. So 2/9 is our fraction of a shortbread biscuit that is made up of sugar. Part B. 1,400 grams of flour is used to make a batch of shortbread biscuits. How many grams of butter is used for this batch of shortbread biscuits? So we're going to move this ratio here down to part B. So flour, butter, sugar in the ratio 4:3:2. Now they tell us that flour is 1,400 grams. So I'm going to pop that there. So I know that flour is worth 1,400 grams. What I'm interested in is how much butter is used in this particular batch. So I'm interested in that column of my ratio there. So I need to find out what has happened to scale up this ratio of flour from 4 to 1,400. So I'm going to do 1,400 divided by 4, which is 350. So every one part of this ratio is worth 350. So we're multiplying by 350. Now I'm only interested in this part here. So I'm going to do 3 multiplied by 350. Which is 1,050. So it's 1,050 grams of butter that are used. Question 2. Lucy bought a car 9 years ago for £12,250. The car depreciated in value by 18% in the first year. In each of the following years, her car depreciated by 15% of its previous year's value. By how much has the car decreased in value in the last 9 years? So this is a repeated percentage change question. You may have heard dealt with some compound interest questions. Depreciation works in the same way. So depreciation means the value is going down. So it's not increasing, it's decreasing. But we've got 2 stages to this. It decreases by 18% in its first year, and then for the rest of the years it decreases by 15%. So I'm going to start with the first year. So for the first year, if it depreciates by 18%, we're starting with 100% of the value and we're taking away 18%. So 100 take away 18 means we're ending up with 82% of the value. Now I've got a calculator, so if I divide that by 100, that tells me that 82% is 0.82 as a decimal. I'm going to use decimal multipliers because it saves me a little bit of time on this calculator paper. So in the first year, the original price was 12,250, but when I multiply it by my decimal multiplier, so multiply by 12,250, it tells me that at the end of the first year, the car is worth £10,045. Okay, the next stage is for each of the following years. So 9 years in total, we've done 1. So for the next 8 years is what we're working out the depreciation value for. So for the following years, it depreciates by 15% of the previous year's value. So we're starting with 100% of this value. So we have 100%, but we're taking away 15%. 100 take away 15 is 85%. make that into a decimal multiplier, so divide by 100. So 85% is 0.85 as a decimal multiplier. So we're doing the previous year's value, so 10,045, multiplied by our decimal multiplier, but the difference here is it's happening over a few years now. So we need to pop that power of 8 for those 8 years. So when we put that in our calculator and press equals, we have 2,737.167324. Now we're dealing with money. When we're working with money, we only want 2 decimal places, remember? So I'm going to round that to 2,737.17. So that's how much the car is worth at the end of the 9 years. We need to know how much it's decreased in value by, so we need to know the difference between this and its starting value. So 12,250 subtract £2,737.17. So £9,512.83 is how much it's decreased in value by. So £9,512.83. Question 3. Regan caught 70 fish on a fishing trip. He measured the length of each of the fish in centimetres. The table shows his results. So we've got a grouped frequency table. So we don't know the exact results, but we know that there were 19 fish that measured between 60 and 65 centimetres, 17 between 65 and 70, etc. Part A, calculate an estimate for the mean length of these fish. So when we're dealing with mean from a frequency table, we need to add in a few columns because we need to work with our midpoint, and then we will multiply our midpoint by our frequencies to get new totals that we work with for the mean. So this is our midpoint column. So the midpoint is halfway between the lowest and highest value within this particular class. So if you can't spot what's the halfway between, do the first and the last added together, so 60 plus 65, and then divide by 2, which tells us 62.5. Be very careful when you're writing in here. Make sure you put your decimals nice and clear so you don't make a mistake later when you're multiplying. Okay, 65 plus 70 for the next one, divided by 2. So that's 67.5. So I can see a pattern here, but I need to be careful and make sure that that pattern follows through. So for sometimes they might have, this has got a difference of 5, but sometimes they might end up having a difference of 10. So just double check that before you spot a pattern. So I know 72.5, 77.5 and 82.5. Okay, so now I multiply my midpoints by my frequency. So 62.5 multiplied by 19 is 1,187.5. 67.5 multiplied by 17, 1,147.5. 72.5 multiplied by 23, 1,667.5. 77.5 multiplied by 10. Some of these, when we're multiplying by 10 or by 1, you might think to yourself, I know what that is. Do it in your calculator anyway, just to be safe, guys, all right? So these are our new totals. So these are the totals that we're working with in the mean now. So I'm going to add those up. So we have 1,187.5, add 1,147.5, add 1,667.5, add 775, add 82.5. Be careful when you're entering those values into your calculator, guys, because one wrong press of your button is going to get you to a wrong answer. Now, I know none of my working out's down here. It really doesn't matter as long as we're not going into these margins, so don't worry about that. So this is our new total. So this is our total lengths of fish. So to find our mean, we're going to do our new total divided by how many fish in total. Well, handily, they tell us that in the question. So we're doing 4,860 divided by 70. Look, it's still in my calculator. I'm saving myself a bit of time by not clearing it. So that is 69.42857143. Now it doesn't tell us to round it in any way, so I'm just going to leave it there, guys. Part B. Regan thinks that the median length of fish is in the group 70 is less than or equal to L, which is less than 75. So Regan thinks that the median length of the fish is here in this class. Is Regan correct? Yes or no? We're not going to click yes or no without thinking about this, guys, and we've got to give a reason for our answer. So when we're working with the median from a grouped frequency table, we have 70 fish in total, so 70 divided by 2 is 35. Do that in your calculator if you need to. So the median class from a group frequency table, the median length of fish is going to be the 35th fish, okay? So we're going to do a little bit, I'm going to change the colour of my pen just to make it a bit clearer, if I can find one. We're going to do a little bit of cumulative addition. So we're starting with 19 here. When we add 17, so 19 plus 17, there are 36 fish in total across those two classes. Now we just worked out that the median length of fish would be the 35th. So 19 are here, and then when we move into the next class, we have 36. So that 35th fish is going to be in this class here, because that's where we ended up counting to 35 and then to 36 for the total. So Regan is wrong. So Regan is not correct. And I'm going to say that's because the median is in the group. And it's this one, remember, because that's where when we were counting up and totaling, we got to our 35th. So it's in the group 65 to 70. So we've said no, that Regan's not correct, and told them why, because that's the correct median. Question 4. Jan has a large piece of card. The card has width 60 centimetres and length 96 centimetres. So we have a diagram of the card here. Width 60 centimetres, length 96 centimetres. She uses a machine to cut identical circles out of the card. Each circle has a radius of 6 centimetres. So now we have a diagram of a circle with a radius of 6 centimetres, and then a demonstration here of how those circles get cut out of this piece of card. Diagram's not drawn to scale, so we can't measure anything directly from these diagrams. So here it says, Jan has cut 5 circles as shown on the diagram above. She continues in this way to cut as many circles as possible from the card. Part A, what is the maximum number of circles Jan can cut out of the card? Okay, so let's have a look at this. We're going to use this diagram here because it's really helpful. So they told us here that we've got a radius of 6 centimetres, which means each of these identical circles have a diameter of 12 centimetres because the diameter is double the radius. So what we can do is say that this distance here is 12. This distance here is 12. This total distance of the card is 60. So if we do 60 divided by 12, we'll see how many circles down will be. So 60 divided by 12 is 5. So there'll be 5 circles this way. We're going to do the other way as well. So remembering that this, try not to use the bobbly part of my ruler, this is 12. This is 12. Remember that the diameter is the same at different orientations as long as it goes from the circumference to the circumference, so one edge to the other, but through the centre. So these are all 12. So we can divide this length by 12. So 96 divided by 12. 96 divided by 12 is 8. So we would have 5 circles down, 8 circles across. So the total number of circles would be 5 multiplied by 8, which is 40. Okay. Part B. Jan cuts out the maximum number of circles, so we've taken them out from the card. What area of card is left over? Okay, so we need to first of all find out what the area of card was before we cut anything out. So we're going to find the area of this rectangle. So 96 multiplied by 60 because it's a rectangle. So that's 5,760 centimetres squared in total for the rectangle. Now we know the dimension of the circles, so each identical circle, the area would be pi times radius squared. The radius is 6 centimetres, so the area would be 6 squared times by pi, which I'm just going to write as 36 pi now. If you don't know what 6 squared is, remember, just do it in your calculator, guys, okay? So 36 pi. But remember, she's going to cut out 40 of them. So we need to do that 36 pi multiplied by 40 for all 40 circles. So 40 multiplied by 36 pi is 1,440 pi. Again, I'm leaving it in terms of pi because I don't want to write out a load of decimals and I don't want to have to put a load of decimals into my calculator. So if Jan is cutting out 40 circles from this and we need to know what's left, we need to subtract those areas. So we're going to do 5,760 subtract the total area of the circles. So I've left 1,440 pi in my calculator. So 5,760 subtract my answer tells me that it's 1,236.106579. Now it doesn't ask me to round it in any particular way, so I'm just going to write that the area is 1,236 centimetres squared. 5a. Expand and simplify. X add 3 multiplied by x add 7. So there's several different ways you can expand double brackets. I'm just going to use arrows to make sure that everything in this bracket gets multiplied by everything in this bracket. So I'm going to start with this x and I'm going to multiply it by the other x. So x multiplied by x gives me x squared. I'm now going to multiply this x by the 7. So x multiplied by positive 7 is positive 7x. So now I've dealt with that x, I'm going to deal with the 3. So positive 3 multiplied by x is positive 3x, and then positive 3 multiplied by 7 is positive 21. So that's going to get me 1 mark for any 3 of those being correct, guys. But it says expand and simplify, so I need to collect like terms for these x terms. So we have x squared, but then we have 7x add 3x. So we have 10x in total with plus 21 on the end there for full 2 marks. Part B, solve. 7x add 6 equals 4x add 7. So I'm just going to write this here so I can organise myself because I like to keep things aligned. So we have the unknown variable that we're solving for, x, on both sides. So the first thing we need to do is eliminate, get rid of the smallest lot of x. Now the smallest lot of x is 4x. 7x is bigger than 4x. This is a positive 4x. I know it's positive because there's no negative sign in front of it. So the inverse would be to subtract it. So when I subtract 4x from 7x, that leaves me with 3x. I've done nothing to the 6, so that stays there. And then I need to subtract 4x from the right-hand side to balance the equation. 4x subtract 4x is what cancels that out for me, guys. And then I'm just left with that positive 7. Now I've got a 2-step equation. And what I'm going to do now is eliminate the add 6. Because what I'm aiming to do is isolate the x term and then solve for x. The inverse of adding 6 would be to subtract 6. So 3x, I've done nothing to the x term here. I'm dealing with numbers only. 6 subtract 6 is what cancels it out. And then when I subtract 6 from the right-hand side to balance the equation, 7 subtract 6 is 1. Now we have a 1-step equation. 3x is 3 multiplied by x. I'm aiming to isolate x on its own, so the inverse of multiplying by 3 would be to divide by 3. So when I divide 3x by 3, I get x. I need to do the same to the right-hand side. 1 divided by 3, be really careful here. It's a common mistake. Write it as a fraction, 1 divided by 3, and leave it like that, guys. Some people make the mistake of reversing that and doing 3 divided by 1. That's not what you're doing. You're doing 1 divided by 3, so leave it as a fraction. Part C, factorise y squared subtract 400. So when we're factorising, we're putting brackets in. So it's the opposite of expanding brackets. Now this is a quadratic, and so we're going to have to factorise into 2 brackets. I know it's 2 brackets because I have a squared term and the number term. Both of those things mean that I need 2 brackets. Now each of these brackets needs to have a y in it, because that's the only way I'm going to make y squared when it gets expanded, okay? This is an example of the difference of 2 squares, so the number that goes inside the bracket is the square root of 400. So the square root of 400 is 20, so I need plus 20 here and negative 20 there. Part D. Solve the following simultaneous equations. You must show all of your working out. Okay, so the first thing when I'm solving simultaneous equations is I need to see if the coefficient of any of the variables match. So I've got 7x and 1x, that doesn't match. I've got negative 3y and positive y, they don't match. But I am going to make my y's match. So I'm going to multiply this equation by 3. When I'm multiplying this equation by 3, everything gets multiplied by 3. So x times 3 becomes 3x, y times 3 becomes plus 3y, and then 3 times 3 becomes 9. So I've scaled up that equation, and then I'm just going to write this one above it for ease. So now you can see that actually the coefficients of my y do match. They're both 3. Doesn't matter that they're different signs, but what matters is that they match. So now it's those signs that I'm going to look at to decide whether I add or subtract these equations, because I'm trying to eliminate one of those variables. So when I look at this, I have a negative and a positive. So to eliminate the y's, the variable that I've made match in terms of their coefficient, I need to add these equations together, because negative 3y add 3y is going to eliminate it and make 0. So the signs are different, we're adding. So 7x add 3x is 10x. 26 add 9 is 35. Now we've got a one-step equation that we can work with to solve for x. So 10x is 10 multiplied by x. The inverse of multiplying by 10 would be to divide by 10. 10x divided by 10 is x. We have to do the same on the other side, remember, to balance the equation. 35 divided by 10. I know that's 3.5, but if you weren't sure, that's what your calculator's for, guys. So I know that the x value is 3.5, so I'm going to write that straight away on my answer line, making sure my decimal point is nice and clear. Now that I know what my x value is, I can substitute it back into one of the original equations to find my y value. So I'm going to use this equation because it looks like the simplest of the two. So if x plus y equals 3, and I know x is 3.5, I'm going to replace that x with 3.5. So 3.5 plus y is equal to 3. So now I'm solving for y. So what I'm going to do to solve for y is eliminate this 3.5, because I want to isolate the y on its own. So this is a positive 3.5. I know it's a positive 3.5 because there's no negative sign in front of it. So to eliminate it, I need to do the opposite, which would be to take it away. So when I subtract 3.5 from the left-hand side, it just leaves me with y. But remember, we have to do the same to the other side. 3 subtract 3.5. I know that that's negative 0.5. If you didn't know that, guys, calculator. So negative 0.5 is my y value. Question 6. The two shapes below are similar. So we've got these two shapes with some dimensions labelled. The diagrams are not drawn to scale, so we can't measure anything directly from them. Find the value of R and find the value of T. So we have R and T here, and we need to find their values. So when we're working with similar shapes, we're working with scale factors. Now, the only information here I've got are lengths, so I'm not dealing with area or volume, I'm working with the length scale factor. So to work out the scale factor, we find the proportional relationship between the larger shape and the smaller shape. So what we need to do is find corresponding sides on the shape that we have the information for. So I know that this side of the shape is 15.6. It corresponds to this side of the smaller shape, which is 10.4. So my scale factor is 15.6 divided by 10.4. We're going to stick that in our calculator. So that tells me that my scale factor is 3/2, or if you're more comfortable working in decimals, my scale factor is 1.5. So the bigger shape is 1.5 times bigger than the smaller shape is 1.5 times smaller than the bigger. And we can use this scale factor now to find our missing lengths. So we're going to start by finding R. So if you look here, R on the bigger shape, this side here corresponds with this side here. So R has a relationship with 7.6 on the smaller shape. So we know the smaller value, we're trying to find the bigger value. So to go from the smaller shape to the bigger shape, we multiply this length by our scale factor. So R is equal to 7.6 multiplied by our scale factor of 1.5. So R is 11.4 centimetres. I'm just going to put 11.4 centimetres on the line at the bottom there. Now we're going to find T. Okay, so T, this length here, corresponds to 19.5 on the bigger shape. So this time we're going from a known bigger value to its corresponding smaller value. So instead of multiplying, we're going to divide because we want it to get smaller. So we're going to do the 19.5 divided by our scale factor of 1.5. So 19.5 divided by 1.5 equals 13 centimetres. So T is 13 centimetres. Question 7. Vaughan cycles down a track from the top of the mountain to the bottom. The track goes down at an angle of 48 degrees to the horizontal. Vaughan is 800 feet above ground level. So we have a diagram here of the mountain, and Vaughan's here is going to cycle from the top to the bottom. This is our 48 degree angle to the horizontal, and this is how high up he is at the top of the mountain, 800 feet. The diagram's not drawn to scale, so we can't measure anything directly from it. Part A. Vaughan cycles from the top of the track to the bottom of the track. What distance has he cycled? So what we need to recognise here is the journey from the top of the track to the bottom of the track actually forms the hypotenuse of a right angled triangle. They've nicely marked the right angle there for us, guys. So we are going to be working with trigonometry because we've got other angles that we know and we're trying to find the hypotenuse. So this right angled triangle, opposite the right angle is the hypotenuse. We don't have another angle marked inside the triangle, but we can calculate this angle because the horizontal forms a 90 degree angle with the side of the mountain there. So if we do 90 subtract 48, which equals 42, we know that that angle there is 42 degrees. Then we can continue to label our triangle. The side opposite the other known angle is the opposite, which means this must be the adjacent. Now, when we're working with trigonometry, we need to identify the sides that we are interested in. So we are trying to find this length here, okay? So we're looking for the hypotenuse. We want to know the distance that he cycled, but we also know the adjacent because they've told us he's 800 feet above ground level. So we're working with the adjacent and the hypotenuse. So this is the cosine ratio. So cosine is equal to the adjacent over the hypotenuse, You may also see it like this in a formula triangle if you're used to seeing SOHCAHTOA in that way. So what I'm going to do is substitute in what I know now. So the cosine goes with the other known angle. So we're dealing with the cosine of 42 is equal to the adjacent, which is 800 feet, divided by the hypotenuse. The hypotenuse is what we're looking for. Now you've got two options here. You can go the algebraic method because you know how to rearrange that to solve for h, or you can use your formula triangle. So h is what we're looking for. So if I cover up h in the formula triangle, a divided by c. So I'm doing, our value h is the adjacent divided by cos 42. So h is equal to 800 divided by cos 42. Always close that bracket just to be safe as habit. And then we're going to write down here. So 1076.5 is what I'm going to write. So the distance he cycled, they don't tell us to round it in any particular way. So I'm just going to round it to the nearest foot, maybe. In fact, no, I'll just write that on mental line, 1076.5 feet. They don't tell us to round it, so I'm not really going to. Part B, state an assumption you have made in answering part A. Okay, so this is something you've assumed when we formed that right angle triangle to find that distance. Well, if you look at this diagram, this line's a little bit shaky, it's a little bit wobbly. We've assumed it's a straight line. So we've assumed that the slope is smooth and not bumpy, because if it was bumpy or if it veered off like a normal cycle track could, he potentially would have cycled further. So I'm just going to have assumed he rode in a straight line and the road was smooth. So I'm assuming it was just a straight line down to the bottom of that mountain. The next part, if your assumption is not correct, what effect would this have on your answer to part A? Well, if this wasn't a straight line and he went off on a wiggly line or over bumps and things, sorry for the hand movement then that's going to have an effect on our answer because he will have cycled further. It's not just one straight line to the bottom, he's potentially cycled further. So if my assumption is not correct, so I'm going to put if the slope is not smooth, he will have cycled further. Question 8. Bjorn is a jewellery maker. So we've got a diagram here. This looks like potentially a silver bar with a special offer 5% discount. Part A, he pays £1,451.60 for a silver bar after a 5% discount has been applied. What was the original cost of a silver bar? So we want to know what it cost originally because this is the price after 5% has been taken off. So I'm going to draw myself a proportion table. We know I like those if you've looked at any of my other videos. So this is the cost and this is the percentage. So the cost of £1,451.60, it's a 5% discount. So the original price was 100%, but then they've taken 5% off. So 100 take away 5 is 95. So that price is 95% of the original because they've taken 5% off. It's after that discount. I want to know the original cost of the silver bar, so I want to know what 100% is. So I'm going to need to scale down and up in this proportion table to get to 100%. So because I've got a calculator, I'm going to make my life easy. I'm going to go to 1%. So to go to 1% from 95%, I divide by 95. I need to do the same to the other side of this table. So 1,451.6 divided by 95. I can do that because I've got a calculator, so I might as well. So that's £15.28 is 1%. We want 100%. So to go from 1% to 100%, we're going to scale up by multiplying by 100. Remember, we do the same. to the other side. So 15.28 multiplied by 100 is £1,528. So the original cost was £1,528. Part B. The silver bar is in the shape of a cuboid and has the following dimensions. So we have length 8.1, width 7.3 and depth 4 centimetres. Bjorn melts down the silver bar and uses the silver to make 200 identical pieces of jewellery. The density of the silver is 10.49 grams per centimetres cubed. Calculate the mass of each piece of jewellery. Give your answer in grams. Okay, so we are dealing with density, mass, and we're going to be using volume because we're dealing with a cuboid. So you may have dealt with a formula triangle like this. Density is equal to mass divided by volume. So let's see what we know. We know what the density is. We're looking for the mass. We don't know the volume, but they've given us all the information we need to find the volume of this silver bar, which is a cuboid. So let's start by calculating the volume. So 8.1 multiplied by 7.3 multiplied by 4. Just check you've put the right things in the calculator. We make mistakes. I've done it on a previous video. We are only human. So 236.52. So that's in centimetres cubed because we're working in centimetres and that's volume. Now we're going to work out the mass. Now that we have the density and the volume, mass is density multiplied by the volume. Okay, so we're finding the mass, density multiplied by volume. So the mass is equal to our density of 10.49 multiplied by our volume of 236.52, sorry. Now this is in grams per centimetres cubed. This is in centimetres cubed, so they match in terms of units, which is why we can simply just multiply them. I've still got the volume in my calculator, so I'm just going to multiply by the density, which is 2,481.0948. So the question asks us to calculate the mass of each piece of jewellery. He's going to make 200, so we need to divide our mass by 200. It's still in my calculator, which makes life easy. So that gives me 12.405474. Now it asks for our answer in grams. We are already working in grams because our density tells us that we're grams per centimetres cubed. Centimetres cubed is the volume, grams is the mass. So each piece of jewellery has a mass of this. You can write rounded however you feel appropriate on your answer line. Question 9. The diagram below shows a scale drawing of Amy's garden. The garden is enclosed by a fence, a patio, a hedge and a wall. In Amy's garden there's a tap, a birdhouse and a water feature. So we're given a scale here. This is important, a scale. So half a centimetre on the diagram represents 1 metre in real life. So Amy is going to spread grass seed on part of her garden, so not the whole garden. The grass seed will be spread over the region that satisfies the following conditions. So it will be at least 8 metres from the water feature, nearer to the birdhouse than the tap, and nearer to the hedge than the wall. On the diagram, clearly indicate the region that is to be spread with grass seed. You must use a ruler and a pair of compasses to construct suitable arcs and lines. So I'm going to keep my calculator for a little bit because I need to convert from metres to centimetres, but then I'm going to move my calculator out of the way because all I need then is a ruler and a pair of compasses. So this is a loci and construction question. So you need a compass, a pencil, you need a ruler. If you're in an exam and you can't find those things or your pencil's not sharp or anything like that, hold your hand up, wait for an invigilator to come along, ask for a compass. Even if what you'll find in your maths pack in schools, those compasses might be really loose ask for a new one. Ask for a tighter one so it doesn't slip and make your life harder. And when you're doing these things with a compass, make sure you've got lots of paper underneath. So like the rest of the exam paper, for example, don't just have one page on a flat surface. It slips anyway. So this scale means we're going to have to convert some measurements. The only measurement given is 8 meters from the water feature. Okay, so 1 meter is half a centimetre. So 8 meters. Do a little bit of a proportion table. We know I like those. So this is on the drawing. This is in real life. Okay, so on the drawing, 0.5 centimetres is 1 metre in real life. We've got 8 meters. We would scale that up. So we would multiply by 8. So I do that on the other side. So when I multiply by 8, 0.5 multiplied by 8 is 4. So I'm doing 4 centimeters here. So I'm going to put that there nice and clearly. That conversion is going to get you a mark, guys. So make sure it's written down and not just in your head like a special secret. So this is the point now where we need to start constructing on our diagram, guys. Now, when you set your compass up, my pencil's attached, but what you need to make sure is the tip, when you put your pencil in, the tip of your pencil doesn't go much further than the tip of your compass. Otherwise, it's going to be really difficult to work with. So you want them to be as lined up as possible, guys, okay, when the compass is in this position, and then it will make your life easier when you're drawing. Okay, 8 meters from the water feature. This is the water feature. 8 meters on our diagram is 4 centimeters. So this needs to be 4 centimeters from one point. So we're simply going to draw a circle around that point. So we're going to set our compass to 4 centimeters. Make sure your compass starts on 0. Guys, some rulers can look a little bit confusing. Line it up with 4 centimeters. And then pop your compass onto the water feature, roughly in the centre of that dot as best as you can. So now you're going to apply pressure on that point that you've put on the water feature, and then you're going to let your pencil glide to draw an arc around your water feature. So every point on that line you've just drawn is exactly 4 centimetres from the water feature. Okay, the next condition, it needs to be nearer to the birdhouse than the tap. So it's got to be closer to the birdhouse than the tap. So we're working between 2 points here, guys. And I'm going to draw a faint line here just to demonstrate to you. If we're working between 2 points with loci and constructions, we are constructing a perpendicular bisector. So for this, again, you need your compass. Now, a perpendicular bisector identifies the points that are exactly halfway between 2 points, okay, or smack bang in the middle of a line if you started with a line. So the first thing you need to do is put your compass on one of those points, and then make sure it's set to over halfway across the line. And then you're gonna again apply pressure, but then let your pen glide, and then leaving your compass as it is, do the same on the other side. Now, the reason why we wanted to go over halfway with our compass when we measured it out was because we want these two arcs to intersect. Because when they intersect, those 2 points that they intersect at, if we join them together and draw a line through, making sure that line goes across our whole diagram, guys. That line there, every point on that line is equal distance between the birdhouse and the tap. We want grass seed to go nearer to the birdhouse, so that tells us that it needs to be on that side of the line, which is helpful. The next condition is it needs to be nearer to the hedge than the wall. So nearer to this hedge than this wall. So we have 2 lines here that form an angle. So here we're going to do an angle bisector. I'm going to need our compass for this as well, okay? So we're going to put our compass point on the point where those 2 lines meet. So we want the hedge and the wall. So hedge and the wall. So the point where they 2 meet. And then what you're going to do is you want to make a mark on either side like that. It doesn't matter what your compass is set to. You can draw a full circle if you want to, but too many lines might get confusing. But just a little mark on each line. And then you're going to take your compass again don't have to change it at this point. Just make sure it's a reasonable width, because if it's too close together, you can struggle to construct with it. So where those marks I've just made cross each of those lines, I'm going to put my compass point on, and then I'm going to draw an arc. And then I'm going to do the same with where it crossed the other line, which is the wall. Draw an arc, and you'll see that those two arcs intersect, which is exactly what we want. So now from the point where the hedge and the wall join and form that angle to this intersection point, we're going to draw a line through them. And we're going to make sure, again, that line goes all the way through our diagram. So what this line tells us is that every point on this line is the same distance from the hedge as it is from the wall. Now, I know it doesn't look like it. It can look confusing, but I promise you it is, okay? So we've constructed everything we need to construct. We've now got to identify the correct region. So let's go through these conditions again. So at least 8 meters from the water feature. So we drew this circle around the water feature. Everything on the line of this circle would be 8 meters. And it wants to be at least 8 meters from the water feature. So it's got to be on this line or past it. It can't be inside the circle, because that will be less than 8 meters. So we're dealing with outside of this circle. It wants to be nearer to the birdhouse than the tap. So we drew this perpendicular bisector, and we want it to be this side of the perpendicular bisector because we want it to be closer to the birdhouse. So on the outside of this circle, beyond, and then on this side of this line. And then nearer to the hedge than the wall, so we drew an angle bisector. This is halfway between the two, but if we want it to be nearer the hedge, we want it to be on that side of the line. So I'm going to mark this for you. I'm going to use a highlighter, guys, but I would recommend that you shade in pencil, because if you shade a wrong region and you want to change it, you can rub it out in pencil. So it wants to be closer to hedge than the wall. So it's got to be this side of that line. But it also has to be on the outside of the circle that we drew around the water feature. But I'm stopping there because it also has to be on this side of that line, because it needs to be closer to the birdhouse. Okay, so it's this area here that I've just highlighted in yellow. I'm going to colour it in as best as I can just to demonstrate. Please shade it a little better than that. My highlighter's running out. So it's really important that you're careful at the end there to make sure you identify the correct region. You don't have to be 100% accurate when examiners mark this. There's an overlay that slots on top of your drawing, and as long as you're within a certain error tolerance, you will be absolutely fine. Leave those construction marks in, guys. Do not rub them out. You will lose marks. Question 10. Make E the subject of the formula. So we have G equals 4E subtract 3F. We are rearranging this formula so that it says E equals. So when we're rearranging formula, we're using inverse operations. So we're acting as though we're solving this equation for E, but we're not going to get a numerical answer because we're dealing with algebraic terms. So the first thing I'm going to do, I'm aiming to isolate the term that has E. So 4E has E, and it's a positive 4E, so I want it to stay there. I want it to stay positive, and then I don't have to do anything with it later. So the first thing I'm going to do is eliminate the negative 3F from the right-hand side. The inverse of taking away 3F would be to add 3F to both sides. So when I add 3F to the left-hand side, it's G add 3F. The 3F hasn't been fully eliminated because it's an algebraic term, it doesn't end up being a numerical value. And then when I add 3F to the right hand side, it eliminates it from the right hand side and leaves me with 4E. Now when we're making E the subject of the formula, we're aiming for it to be just E, so 1E. So I need it to be 1E. This is 4 multiplied by E. The inverse of multiplying by 4 is to divide by 4. 4E divided by 4 is E. But remember, we have to balance the equation, so we also need to divide the other side by 4. Now, this is the important thing here, guys. Everything on this side gets divided by 4. So I'm going to write everything on that side as the numerator of a fraction with 4 on the bottom, because that's what I'm dividing by. So E equals G add 3F, all divided by 4. Question 11. Some boxes of medicine must be stored on shelves in a refrigerator. So this is the refrigerator. The vertical height between the shelves is 38 centimetres, correct to the nearest centimetre. 7 identical boxes of medicine are stacked on top of each other on one shelf. Each box of medicine has a height of 45 millimetres, correct to the nearest millimetre. What is the largest possible gap between the top of this stack of boxes and the shelf above? Okay, so we're dealing with upper and lower bounds here, guys. And we've got 2 measurements here that we need to work with. So let's deal with the height between the shelves. Okay, so it's 38 centimetres, correct to the nearest centimetres. So we want the upper bound and the lower bound. So if it's correct to the nearest centimetre, the upper bound, half of 1 centimetre is 0.5. So the upper bound is 38 plus 0.5. And the lower bound would be 38, subtract that half of a centimetre. Then we've also got these identical boxes. So each box has a height of 45 millimetres. Noting the difference in measurements here, that might be important later. Correct to the nearest millimetre, so correct to the nearest one. So we want the upper bound and the lower bound here as well, guys. So the upper bound, correct to the nearest one, the upper bound is 45 plus a half of that, so it's 45.5 millimetres, and the lower bound is 44.5. Remember, centimetres, millimetres, let's not forget that. So we want the largest possible gap, so we want to work with the smallest possible dimensions the boxes could be, but the largest possible dimension that the gap between the shelves could be. So the largest dimension that the gap between the shelves could be is 38.5, but the smallest for the boxes is 44.5. So they're the values that we're working with, because we're going to subtract the total height of the boxes using the smallest value from the biggest total height. So that's going to give us our maximum value between. So we have 7 of these boxes. So we're going to do 7 multiplied by 44.5 to start off with. But we're remembering that this is in millimetres, so we're going to have to convert it to centimetres. There are 10 millimetres in a centimetre, so we need to divide by 10. Okay, so that's the total height of the boxes. That's the smallest total height it could be. So we're going to use the maximum height between the shelves, and we're going to subtract the smallest possible height of the 7 boxes, because that's going to give us our maximum value. So 38.5 subtract my answer that I left in my calculator is 7.35 centimetres. So the largest possible gap is 7.35 centimetres. Now, I chose to work in centimetres. You could have just converted everything to millimetres. It doesn't matter which way round, as long as your answer's correct for that particular measurement. Question 12. The equation 2x cubed subtract 3x squared subtract 2 equals 0 has only one positive solution. Akriti says the positive solution lies between 1.81 and 1.82. Is Akriti correct? Yes or no? Show calculations and explain your decision. So we're not going to impulse answer. We're not ticking any of these boxes till we've done some working out to decide whether or not he's correct. So for solutions to lie between particular values, we're going to have to substitute these 2 values into this equation and then compare those results and see what we think. So we're going to start with 1.81. So we have 2. Wherever there's an x, I'm substituting 1.81. So 1.81 to the power of 3 subtract 3. Again, we've got an x. So 1.81 squared, subtract 2. Okay, so I'm going to pop that into my calculator nice and carefully, making sure I don't put anything in wrong. Subtract 3. The brackets are important, 1 for the powers and 2 to deal with the fact that we're taking away things as well. Just makes life a little bit easier. So when I press that, I get 0.031182. I'm going to do the same for 1.82. So it's the same, but it's 1.82. Now, because this is still in my calculator, I can arrow back and it'll take me on to my sum. So I'm just going to go back, and everywhere it says 1.81, I'm going to delete it and change that 1 to a 2, so it's 1.82. Make sure you do it everywhere that you put 81, and then press equals. So our answer is 0.119936. Okay, so we're going to look at these. If a solution to this equation lied between these two values, what we would see is a sign change. So one of them would be positive and one of them would be negative. We don't see that. So we can say he's not correct. A solution does not lie between those, but we have to explain why. So one should be positive and the other should be negative. Question 13. The same home learning task was given to 50 Year 7 pupils in School A and 50 Year 7 pupils in School B. The length of time in minutes each pupil took to complete the task was recorded. Part A. The results for pupils from School A are shown on the cumulative frequency diagram below. So here we've got cumulative frequency and time taken. Use the cumulative frequency diagram to answer the following questions about the pupils in School A. So the first question, what is the median time taken to complete the task? So median is middle. Now we have 50 pupils in total. 50 divided by 2 is 25. Again, do that on your calculator if you need to. So we're going to read across from 25 on our graph and then down to see what the median time taken is. Now we need to use a ruler. I'm going to use a pen so that you can see my lines really clearly on this grid. I recommend you use a pencil just to be safe. So we decided that the midpoint is 25, so we're going to go up to 25. So from 20 to 30 is 10 squares. So each square must be 1, so that must be 25. So I'm going across from 25 to where it meets my cumulative frequency graph. And then where it meets the graph, I'm going to come down to the axis that measures time. And then I'm going to read off this value. So from 30 to 40, there's 10 little squares, so each square must be 1. So this must be 39. So I'm going to say that the median is 39 minutes. The second part, calculate the interquartile range of the times taken to complete the task. So the interquartile range is the upper quartile subtract the lower quartile, okay? So quartiles, we're dealing with quarters. So if 25 is the middle, that's 50%. A quarter is half of that, okay? So my lower quartile is at 25. 25 divided by 2, which is 12.5. If you didn't know that, please remember calculator. So we're going to read across from where 12.5 is. So 12, 12.5. Be as accurate as you can and read across to the cumulative frequency line and then down, okay? So our lower quartile comes down at 30 minutes. Now our upper quartile, our lower quartile is at a quarter, which was 12.5. Our upper quartile is at 3/4. So it's going to be at 25 plus 12.5. So upper quartile is 25 plus 12.5. 37.5. So we're going to find 37.5 on our graph. So 35, 6, 7. So 37.5. So it's halfway there. So we're going to, as accurately as we can, draw across to our curve. So that's our 37.5. And then we're going to go down to our time and read off our upper quartile. So that's roughly 51. So our upper quartile is 51. So we're going to do 51 subtract 30, which is 21. So we're going to say that our interquartile range is 21 minutes. Now, when they mark this in the exam, there is an error. There's a buffer for error, and usually it's a range of values. So anywhere between 19 and 21 here is going to get you those marks. Okay, part 3. What percentage of pupils took longer than 62 minutes to complete the whole home learning task? So we're going back to our cumulative frequency graph. We're looking for people that took longer than 62 minutes, okay? So we're going to look for 62 minutes on our time axes here, and then we're going to draw a line up to our cumulative frequency curve, and then we're going to draw across this time to read off at our cumulative frequency axes. So 40, 41, 42, 43. So from 43 to 50 people in total took longer than 62 minutes, okay? Because that's this side. So 50 take away 43 is 7. So 7 pupils took longer than 62 minutes, but we want a percentage, 7 out of 50. So we're going to do 7 out of 50, and then we're going to times that by 100 to get a percentage. You could also just scale up to a denominator of 100, whatever works better for you. So we're going to go with 14% there for that part. Okay, part B. A summary of the results for pupils in School B. So all of the other parts dealt with School A. We're now on School B. Is shown in the table below. So we have the least time, the lower quartile, the median, the interquartile range, and the greatest time. And they want us to draw a box plot to display the results for School B. They've given us a scale, they've given us a place to draw it. Okay, so when we're drawing a box plot, please use a pencil, but I'm going to use a pen so that you can see it nice and clearly. So our whiskers are our least time and our greatest time. Our scale's in minutes, our least time is 12. We're just checking our scale. 10 to 20 is 10 small squares, so each must be 1. So this is 12. So I'm going to draw the whisker for my least value here at 12. I'm also going to draw the whisker for my greatest value, but currently it's in hours and minutes. I'm working in minutes. So 1 hour, 5 minutes is 60 minutes for the hour plus 5. So my greatest time is 65 minutes. So I'm going to draw a whisker the same length. So that's my least time and my greatest time dealt with. Okay, my lower quartile falls at 31 minutes. So 31 is here. So I'm going to draw a line there. So this is my lower quartile. My median is at 45 minutes. So 40, 45. Now it says here that my interquartile range is 24 minutes. So my interquartile range is the difference from the lower quartile to the upper quartile. So I need to add 24 minutes to 31. So 31 plus 24 is 55 to find where my upper quartile lands. So my upper quartile lands at 55, which is here. And then it's a case of, now we've dealt with all the piece of information, completing this diagram. So my lower quartile and my upper quartile are joined to form the box for this plot, and the median is also in there. And then the least value and the greatest value are simply joined to that box by a line which forms those whiskers. Okay, part C. Make 2 comments to compare the results of School A and School B. 1 comment must include an appropriate average. The other comment must include a measure of speed, so a measure of spread. So a measure of spread is your interquartile range. An appropriate of average is probably, we're going to be looking at our median value. Okay, so we're going to make 2 comments. We're going to make 1 comment on our median and 1 comment on our interquartile range. So let's just compare these things. So the median for School B is 45 minutes. We found the median for School A to be 39 minutes. I'm just going to pop that there because I want to be able to compare them, but it's on the other page. And then we said we're also going to look at the interquartile range for the spread. So the interquartile range of A is 21, but for School B it's 24. So A is 21. So I'm going to make a note of those there because they're what I'm going to use to write my comparisons, and then I don't have to keep flipping back on the pages. So my first comment is going to be on the median. So if we look at the median value, School B has a 45-minute median, School A has a 39-minute median. School A's median is lower, so on average, School A were quicker. So I'm going to say that on average, School A were quicker with a median of 39 minutes compared to School B with a median of 45 minutes. So I've made direct reference to the medians and what that tells us. Okay, my next comment is on interquartile range. So interquartile range tells us the spread of the data. So it tells us the consistency of that data, okay, and how varied they were. The smaller the interquartile range, the less varied the data. The larger, the more varied or the less consistent. So let's have a look at the interquartile range then. So the lower the interquartile range, the more consistent. Okay, so School B has an interquartile range of 24. School A has an interquartile range of 21. So actually School A's got the lower interquartile range, so their values are less varied and more consistent. So I'm going to say that. So School A's results were more consistent with an interquartile range of 21 compared to School B's interquartile range of 24 minutes. Question 14. The diagram below shows a square-based pyramid. The slant height of each triangular face is 12 centimetres. So the diagram's not drawn to scale. We can't measure anything directly from it. We have a square base with a side length of 9 centimetres, and then we have the slant height of each triangular face being 12 centimetres. Calculate the volume of the pyramid. You must show all your working out. Okay, so the formula for the volume of a pyramid is 1/3 times the area of the base times the height. So that B is area of base. Okay, the height is the important thing here, guys. It's the perpendicular height. So it's the height that goes from here to right down into the center of that square base. We don't know this yet. Okay, we don't have that information. So we're going to have to find that out before we can use the formula for the volume of a pyramid. So what we need to be doing here is forming ourselves a right angled triangle. And I can do that. I was going to use the bobbly part of my ruler then. If I draw a dimension there, we are now working with a right angled triangle. Now this is 3D Pythagoras. You've got to be able to visualize this guys, to work with it, okay? So we're working so that perpendicular height will form a right angle with the base of the pyramid. So we have a right angle triangle. We know the slant length, which is the hypotenuse, is 12. We're looking for this side, the perpendicular height. We need to know this side. Now the side length of the square is 9 centimetres. This height would end up smack bang in the middle. So this is half of 9 centimetres. Okay, so 9 divided by 2 is 4.5. So that length there is 4.5 centimetres. So we're going to use Pythagoras' theorem to find the height of this triangle to then use it in our formula for the volume of the pyramid. So Pythagoras' theorem, a squared plus b squared equals c squared. Okay, c is always the longest side, the hypotenuse. So c squared is 12. A and b, so let's call a our height and let's call b our length of 4.5. So h squared plus 4.5 squared, 20.25 is equal to 12 squared, 144. So h squared is equal to 144, subtract 20.25. So h squared is equal to 123.75. That's h squared. We want the height, so we are going to have to square root. So 123.75 square rooted. So square root my answer, which gives me 11.124297773. Okay, so that's the height. I'm going to leave that in my calculator because that's a big decimal and I don't necessarily want to have to type that in loads because I know I'm going to need to use the height for the volume. Okay, so now we're working out the volume, guys. So it's 1/3 multiplied by the area of the base, so the area of the square base. So 9 times 9 because all sides on a squared are the same. So 9 times 9. Or you can write it as 9 squared, whichever would make more sense to you. And then we're multiplying it by our height. So we're multiplying it by our 11.12, etc. So I haven't deleted that off my calculator because I don't want to have to type it all in again. So I am going to not clear anything. I'm going to do 1/3 multiplied by, I'm entering it in exactly as I've written it on my piece of paper. You might have wrote 9 squared, absolutely fine. And then we're multiplying it by our height, which was our previous answer. So I'm going to press my answer button and press equals. Okay, so it equals 300.3560387. So this is the volume of our pyramid. It doesn't tell us to round it in any way. So just be careful when you do. Make sure you've shown them the full thing. But I'm going to round it to 300.4 centimetres cubed. Question 15. Cody has a bag containing 8 red sweets and 9 green sweets. Cody randomly selects one sweet at a time and eats it. Part A, calculate the probability that the first 2 sweets he eats are red. Okay, so let's work out some probabilities then. So the probability that we select a red, well, that Cody gets a red sweet. So we have 8 plus 9 sweets in total. So 8 plus 9, do everything on your calculator if you need to give your brain a rest. So we have 17 sweets in total, 8 of them are red. So the probability of a red is 8 out of 17. The probability of a green is 9 out of 17. Okay, so he's going to select 2 sweets and we want the probability that they're both red. So the first sweet he selects would be 8 over 17 as a probability. However, he's eating that sweet. So the next time he selects a sweet, he's only got 16 of them left. If the first sweet he eats is red, and then the second one is also red, he's got one less red that he can pick from as well. So his probability would be 8 over 17 multiplied by 7 over 16. Put that in your calculator, guys. It's a calculator paper make your life as easy as possible. So we have 7 over 34 as our probability that the first 2 sweets Cody eats are red. Part B, calculate the probability that the first 2 sweets Cody eats are the same colour. Okay, so this means we are working with the probability of red multiplied by the probability of red, which we already worked out. But we're also then doing the probability that it's green and green for the first 2 sweets, so the same colour. So we need to work out this probability first. So the first sweet he picks has a probability of 9 over 17 being green. However, he eats the first sweet, so when he picks the second one, he has 1 less in the bag to pick from. If the first one he picked was green, then he has 1 less green to pick from when he picks the second one. So let's stick this into our calculator. 9 over 17 multiplied by 8 over 16. So the probability that both sweets are green are 9 over 34. Okay, so we want the probability that the first 2 sweets he eats are the same colour. So it's 7 over 34, or, so we're adding 9 over 34. Denominators are the same, wonderful. You could also just stick that straight in your calculator, because then if there's any simplifying to be done, your calculator is going to do it for you. So that becomes 8 over 17 in total. So that's the probability that the first 2 sweets he eats are the same colour. Question 16. The trapezium shown below has an area of 59.5 centimetres squared. So here's our trapezium. We've got some algebraic dimensions labelled, but the diagram's not drawn to scale, so we can't measure anything directly from it. Show that 6x squared subtract 7x subtract 3 equals 119. Hence, find the height of the trapezium. You must show all of your working out. So we are going to be forming an expression for the area of this trapezium because they've given us the area value. Okay, so we're going to start there. So to find the area of a trapezium, the first thing we do is add the 2 parallel sides together. So we're going to do that. We have x plus 1 plus 2x. Okay, collecting like terms here, guys. So you have x plus 2x. Remember, the sign in front sticks with it. So that's 3x plus 1. Then we would multiply that by the height, the perpendicular distance between them, which is 2x subtract 3. So I'm doing 3x add 1 multiplied by 2x subtract 3. I've written brackets around both of those because there's more than one term in each dimension. So I have to remember that I am working with double brackets, and I now need to expand those double brackets. When I'm expanding brackets, everything in this bracket gets multiplied by everything in this. So I'm going to start with the 3x. 3x multiplied by 2x. 3 multiplied by 2 is 6. X multiplied by x is x squared. Now I'm going to multiply the 3x by the minus 3. 3 multiplied by minus 3 is minus 9. And then we've got the x, so that's minus 9x. I've dealt with the 3x. I'm now going to deal with the plus 1. Positive 1 multiplied by 2x is plus 2x, and then positive 1 multiplied by negative 3 is negative 3. And I'm going to simplify here again because I can collect like terms with my x terms. Remembering that that negative stays with the 9. This is negative 9x. It's attached plus 2x. So we're starting at negative 9. We're adding 2. Now, if you're not great with negative numbers, put negative 9 plus 2 in your calculator, guys. So we have 6x squared subtract 7x subtract 3. Now this is our expression nearly for the area of a trapezium. The next thing we would do would be to divide everything by 2. So the area of the trapezium would be a half this expression. And we know that the area is 59.5 centimetres squared. So we're going to write that equal to 59.5 centimetres squared. Now we're getting close to this. Look, we've got 6x squared, subtract 7x, subtract 3. What they don't have is that half in front. So to eliminate the half, we're going to multiply everything by 2. So this gives us what's left inside the bracket because it simply eliminates the half. But then we're going to do 59.5 multiplied by 2, which is 119. So we've done the first part, guys. We've shown that 6x squared subtract 7x subtract 3 equals 119. Now we need to find the height of the trapezium. So the height of the trapezium is 2x subtract 3. So we're now going to have to solve this quadratic equation to find x and substitute it in to find the height. So I need to make this equation equal to 0 to be able to solve it. So I'm going to have to subtract 119. So that gives me 0 here, but negative 3 subtract 119. So negative 3 take away another 119. Remember, your calculator can help you with these, guys. Okay, so now we have a quadratic equation equal to 0 that we're going to solve. Now there's a couple of different ways you can do this. You can factorise to solve, or you can use the quadratic formula. I'm going to use the quadratic formula to do this. So x equals minus b plus or minus b squared minus 4ac square rooted all over 2a. So my a is 6, my b is negative 7, and my c is negative 122. So I'm going to substitute those in to start off with. So minus b changes the sign of b. So this is 7 plus or minus negative 7 squared minus 4 times a times c. And this is all square rooted and all over 2 times a, which is 2 times 6. So x equals, I'm going to stick that in my calculator, but I'm going to be very careful, guys, okay? So we've got a fraction, we've got 7. I'm just going to do the positive version. So 7 plus the square root of negative 7 squared, brackets are important, minus 4 times 6 times negative 122. Look, I missed out a bracket there. Be really careful. Easy mistakes to make. All over 2 times 6. So my positive value is 5.13. I'm going to arrow across. Just check that I don't get another positive value because it's plus or minus. So let's put the minus there. Yeah, that gives me a negative value, okay? I'm not going to use the negative value because I can't have a negative height. So this is my x value to work out my height. Now my height equals 2x subtract 3 here. So I'm going to substitute that x value in. So 2 multiplied by 5.13 subtract 3 equals 2 multiplied by 5.13 subtract 3 equals 7.26. So my height is 7.26 centimetres. Question 17. Frederick has a circular watch. So here's the watch face there. Part A, the hour hand has a length of 11 millimetres. So here, look, 11 millimetres. Find the area of the sector covered by the hour hand as it moves through an angle of 131 degrees. Okay, so as it moves through an angle of 131 degrees. So we're dealing with area of a sector. So the formula for the area of a sector is theta over 360 multiplied by the area of a circle. So pi times radius squared. Okay. So we're finding the area of the sector covered by the hour hand as it moves through an angle of 131 degrees. So our theta, our angle, is 131 degrees over 360 multiplied by pi. Now the radius is going to be the length of the hour hand. So the radius is 11 squared. And I'm going to pop that into my calculator. So 138.326 0.0699 millimeters squared, because we're working in millimeters. Okay, doesn't tell me to round it, so I'm not going to. Part B, the minute hand of the watch has a length of y millimeters. How far does the tip of the minute hand move in 21 minutes? Give your expression in its simplest form in terms of pi and y. Okay, so how far does the minute hand move? We are dealing with the length of the arc. So this was the area of a sector. We're now dealing with arc length. So the formula that we're going to use is the angle divided by 360 multiplied by the formula for circumference, which is pi times diameter. Okay, so the angle over 360. Well, actually, the minute hand's is moving 21 minutes. A full circle is 60 minutes. So we're going to disregard this a little bit and go with 21 minutes out of 60 minutes. So we're not working with angles, we're working with minutes. But it's comparable because 60 is a factor of 360. So 21 out of 60 minutes is how far it's moved. That would be the angle that it's covered. And then we're multiplying by pi, and then we're multiplying by the diameter. Okay, now the radius is y. Okay, so the radius is y, so the diameter must be double that, which is 2y. So we are doing 21 over 60 multiplied by pi multiplied by 2y. So I'm just going to evaluate this part and then multiply by 2. Everything's being multiplied together, but it's just that front part I'm going to evaluate. So 21 over 60 multiplied by pi multiplied by 2, which tells me that it's 7 over 10 pi y. Okay, guys, you can write that as 7 pi y over 10, or you can write it as 0.7 pi y. Doesn't matter. Either one of those things is going to get you the marks. Question 18. A car driver is having a tyre replaced at Eduqas garage. The waiting time in T minutes is inversely proportional to the square of the number of mechanics working on that day. If there are 3 mechanics working, the waiting time is 38 minutes. Part A, find a formula for T in terms of M. Okay, so we're working with inverse proportion here, guys. So T, the waiting time, is inversely proportional to the square of the number of mechanics, so to M squared. So T is equal to K over M squared. K is our constant of proportionality. So we are given an M value and a T value that corresponds. So 3 mechanics, the waiting time is 38 minutes. So I'm going to substitute those 2 values in to find K, my constant of proportionality. So T is 38, M is 3, but we're working with M squared. So K must be equal to 3 squared multiplied by 38. So 3 squared multiplied by 38 is 342. So K is 342. So my formula for T in terms of M is this, but with my K value now included. So T equals 342 over M squared. Part B. The garage wants to reduce the waiting time to no more than 12 minutes. What is the least number of mechanics that should be working to achieve this? So remember, time is T, mechanics is M. We've got a formula here now that gives the relationship between time and mechanics. So we're going to use that. Okay, so we're looking for the least number of mechanics that should be working to achieve a time of 12 minutes or less. So I'm going to rearrange this formula now to solve for M. Okay, so I'm going to substitute in my T as 12. So 342 over M squared. When I multiply by M squared, I'm left with this. But to find m squared, I'm going to do 342 divided by 12, which is 28.5. Now, m squared, but I want to know the number of mechanics, so I'm going to square root that value because that's m squared. So I'm going to square root my answer, which gives me 5.3385 mechanics. Well, I can't have 5.3385 mechanics, so I'm going to need 6, I believe. And I'm going to make it nice and clear, because I've used a lot of space, that it's 6 mechanics. Question 19. So we have a diagram not drawn to scale, so we can't measure anything from it, but we've got some side lengths and some angles labelled. It tells us to calculate the size of angles CBD. So remember that little symbol? That's the angle that we're looking for. So if we go CBD, we're looking for this angle here. Okay. Now, we can work with these two separate triangles, which is useful because actually to find this angle, I'm either going to use the sine rule or the cosine rule, because neither of these triangles are right angled. So we're using further trigonometry. But to be able to work with this triangle that includes my angle of x that I'm looking for, I need more information. Okay, so there are a couple of options here. But the first thing I'm going to do is I'm going to calculate the length of BC, and I'm going to do that by just using this triangle here. Because I've got two sides in the included angle, I can use the cosine rule. Okay, so I'm going to find BC. So BC squared equals 8.3 squared plus 6.4 squared, subtract 2 times 8.3 times 6.4 times cos of the angle, which is 71. So you could stick all that in your calculator, but what I am going to do is just calculate a few values so that I don't make a mistake entering that big thing into my calculator. So 40.96. So 2 times 8.3 times 6.4 is 106.24 multiplied by cos 71. So 68.89 plus 40.96. So this simplifies a little bit further to 109.85 subtract 106.24 cos 71. Now I am going to stick that into my calculator. So 109.85 subtract, and I'm going to put this in a bracket just to be safe. I'm always a little bit paranoid when I'm dealing with things. I'm closing my cosine bracket and I'm closing that bracket. When I've got a negative there, I just put an additional bracket in for safety. So this tells me that BC squared is 75.26163927. I want BC. So I'm going to square root this, guys. So 75.26163927. Haven't deleted it because I want to make my life easier. So square root of my answer is 8.67534667. So that's BC and it's in centimetres. So I'm going to put 8.67. It would be rounded differently, but it's just so I remember that this links to this. Okay. Now, we need to look at this triangle now. So triangle CBD. So I have two sides. The included angle is x. So what I could do is I could use the cosine rule, but then to solve for the angle. Or I could use the sine rule, which is this angle and this side, and then this side to find this angle, and then take them away all the way from 180. So whichever works best for you. I'm going to use the sine rule, okay? And I'm going to use the sine rule with this side and this angle, and BC and this angle. And I'm using it to find this angle, guys. So when I'm using the sine rule to find an angle, we flip it upside down. So it's going to be sine of my angle that I'm looking for So let's call that y. So sine of y over the corresponding side is equal to sine of 68 over its corresponding side. So sine y is equal to 8.67 multiplied by sine 68 over 11.1. But then to get y, I would do the inverse sine of all of this. So 8.67 multiplied by sin 68 over 11.1. So I'm going to do that in my calculator, guys. So to get the inverse sine, press shift and the sine button. So I have 8.67 multiplied, and then I'm going to use the fraction button for this. Sin 68, close that bracket. 11.1, arrow away from my fraction, close the big bracket and press equals. So y equals 46.40281709. Okay, so let's go 46.4 degrees for that angle y. So now this is a triangle. Angles in a triangle add up to 180. So 180 take away 68 and 46.4 will give me the angle that I'm looking for, x. I haven't given myself a lot of space, but we're going to write it down anyway. So 180 subtract 68 subtract 46.4 equals. So 180 minus 68 minus my previous answer is 65.597. So I'm going to write that as 65.6 on my answer line. Question 20. So we have a diagram drawn here and we have got a region identified and 3 straight lines have formed that region. So this is inequalities, guys. So inequalities from regions. Part A, complete the following table. So we've got a table here to show the inequalities that describe the shaded region above. And they've given us one. They've said y is less than or equal to 4. Okay, so y is less than or equal to 4 is this line here. Y is less than or equal to 4. It's a horizontal line through 4 on the y-axis, and the part of the graph that's shaded is below that, so it's the values that are less than or equal to 4. We need to find the inequalities that are this line and this line. So this is the easiest one to work with. So a horizontal line through the y-axis is a y line. A vertical line through the x-axis is an x line. So this line links x and -2, but what we need to recognise is what's happening. So it's a dotted line, so we're not going to have an equal to symbol, but we're interested in this side of the line because that's the bit that's shaded. So the values of x on this side of the line get bigger, so they are greater than -2. We don't put an equal to because it's a dotted line, but I'm going to write x is greater than -2 in there. So now the final line that we're working with is this line here, okay? And it's a straight line, so it's going to be in the form y equals mx plus c. Remember that m is your gradient and c is your y-intercept. So the y-intercept of this line is nice and easy. It's +1. But we need to figure out that gradient. So we're going to identify 2 exact coordinates. So I've done one of them there. 0, 1 is a coordinate. And then this point on the line here is at -1, -2. And I'm going to form a triangle here to identify the gradient of this line. So the gradient is the change in y. So the change in y over the change in x. So the y has gone from -2 to 1. So that's a change of 1, 2, 3 in the positive direction. And then it's gone from -1 to 0, which is a change of 1 in the positive direction. So the gradient is 3. So y equals 3x, add 1 is the equation of the line. However, we're working with inequalities. So we need to look at the area that is shaded on this side of the line and decide whether we're going to be using a less than or an equal to, a less than or a greater than symbol to start off with. So because it's above the line, we are using a greater than symbol. So y is greater than 3x plus 1, but it's a solid line. So we need that equal to as well. So y is less than or equal to 3x, add 1. Part B, the line AB. So this line AB is shown on the diagram. The diagram's not drawn to scale, so we can't measure anything directly from it. They want us to show that the equation of the perpendicular bisector of the line AB is 4y equals x plus 9. So to be able to find the perpendicular bisector of the line AB, we need to start by finding the gradient of the line AB. So remember, the gradient is the change in y divided by the change in x. So the change in y, so the y coordinates to start off with, we've got 10 to negative 6. Now we're starting at 10 and we're going down to negative 6. So to get from 10 to negative 6, we've gone down 16 places, okay? And then when we're dealing with the change in x, we've started at negative 3 and we've moved to 1. So the change in x is a positive movement from negative 3 to 1, and it's a movement of 4. So the gradient is negative 16 over 4, which is negative 16 divided by 4. If you're not sure what that is, let's put it in your calculator. So the gradient of AB is negative 4. Now we're working with the perpendicular bisector of this line. So the perpendicular bisector has a negative reciprocal gradient. So we change the sign of the gradient and we write its reciprocal. So the gradient of the new line is equal to the positive reciprocal of 4. So the reciprocal of 4 is a quarter, and it's a positive. So that's the gradient of our perpendicular bisector. So this is going to get you a mark, and this is going to get you a mark. Now what we would do is a straight line has the form y equals mx plus c, and we would substitute that gradient in. So we have y equals a quarter x plus c. And then we would use a coordinate that is common to both lines to substitute for y and x to get c, okay? Now we haven't been given a coordinate that perpendicular line cuts through, but because it's a perpendicular bisector, it's going to bisect this line exactly in the middle. So if we find the midpoint, that's a coordinate that's common to both lines. So we're going to find the midpoint of AB to start off with. So we have got our coordinates here. So to find the midpoint, we want to go halfway between the x coordinates. Now we said that the x coordinates from negative 3 to 1 is 4. Half of that is 2. So add 2 to negative 3. The x coordinate is going to be negative 1. Let's look at our y coordinates. We're going from 10 to negative 6. We said that was a difference of 16. Half of 16 is 8. So we're going to take away 8 from 10, which gives us a y coordinate of 2. So this is now a common coordinate for the line AB as it's the midpoint, and the perpendicular bisector as that's where it would intersect the line AB at a 90-degree angle. We're now going to use these two values for x and y to calculate the c, the y-intercept, for the perpendicular bisector. So y is 2 when x is negative 1. So negative 1 multiplied by a quarter is negative a quarter. So c is equal to 2 plus 1 quarter, which is 2 1/4 or 2.25. I'm now going to substitute that c value in. So the equation of the perpendicular bisector is y equals 1/4 x plus 2.25. However, if we compare this with what the form they've asked us to give it in, we haven't got a fractional gradient of x and we have 4y. So what we need to do is multiply this equation by 4. Y multiplied by 4 is 4y. 1/4 x multiplied by 4 just gives us x. And 2.25 multiplied by 4 gives us 9. Everything gets multiplied by 4. So we've shown that the equation of the perpendicular bisector of the line AB has this equation. Question 21. For two events A and B, the probability of A union B is 0.66. The probability of A intersection B is 0.07. And the probability of A and not B is 0.31. Part A, by completing the Venn diagram or otherwise, so you don't have to use the Venn diagram, find the probability that B occurs and A does not occur. Now I am going to use the Venn diagram because it's a really useful tool to organise information that I'm given. Okay, so let's think about what these mean. So A union B, so the probability of it being in A or in B is 0.66. So that doesn't help us at the minute, but it will help us eventually. The probability of A intersection B is 0.07. Now that intersection B is the middle part of the diagram. So I'm going to use this, I'm going to put 0.07 in the middle there. Okay. So the probability that it's in A union B is equal to 0.66. So the probability that it's anywhere in this diagram is equal to 0.66. Okay, so the next thing I'm going to look at is this probability. So this is the probability that it's in A, but it's not also in B. That's what the complement means. So it's in A and not in B. So this is the in B bit, but if it's in A and not in B, this must be 0.31. Now we're going to go back to this probability here. So the probability of A union B is 0.66. The probability that's within these circles is 0.66. So I'm going to do 0.66 subtract 0.31 subtract 0.07. So 0.66 subtract 0.31 subtract 0.07 is equal to 0.28. So this must be 0.28. Probabilities have to add to 1. So this here is 1 subtract all of these. So 1 subtract 0.31, subtract 0.07, subtract 0.28. Is 0.34. Okay, so I've completed the Venn diagram. I'm now going to find the probability that they're interested in. So the probability that B occurs and A does not occur. So we want the probability that it's in B, but it's not in A. Well, that's just this section of the Venn diagram here, because the middle bit is also in A, but this bit is just in B. So the probability that B occurs and A does not occur is 0.28. Now you could have done that without completing the whole diagram, but I like to complete my thought processes. Part B, find the probability that it's in A or not in B. Okay, so to do this, I'm just going to draw a few little diagrams to explain it to you. Please ignore my attempt at drawing Venn diagrams. So what I'm going to do is I'm just going to split this probability up into 2 Venn diagrams so you can visualize what's happening here, guys. So I want it to be in A. So what I am interested in is anything that's inside the A circle. So the probability that it's in A or the probability that it's not in B. So not in B would be the whole of the diagram apart from anything within the B circle. Told you my diagrams are rubbish. Okay. So when I compare those two things, the whole of A is coloured in here. So the only thing that's not coloured in is this part of B here. So that's the bit that I'm interested in. So I'm going to do probability sum to 1, subtract this probability, which is 0.28. 1 subtract 0.28 is 0.72, so that's the probability that we're looking for. 22a, write y equals x squared subtract 4x subtract 1 in the form here where a and b are constant. So we are completing the square, guys. So when we're completing the square, we've got our x. The a inside the bracket here is half of the coefficient of the x term. So half of -4 is -2. that bracket is all squared. When we're completing the square, the first thing we need to do is square this value inside. So negative 2 squared is 4. I have to subtract that from the outside, but I also remember that there's a negative 1 on the end here. So now I'm going to simplify this. So I have my bracket of x subtract 2 all squared, negative 4 subtract 1. I know that that's negative 5, but if you're not sure, stick it in your calculator, guys, and that's our final answer. A and B are both constants. Part B. On the diagram below shows a sketch of y equals f of x. This is y equals f of x. On the same diagram, sketch y equals f of x subtract 2. Mark clearly any coordinates of any intercepts with the axes. So these coordinates here are our intercepts. So when we sketch our new diagram, those are the coordinates that we're going to label, but in their new position. So this is transformations of graphs. So when we're working with inside of the brackets with the x, it's the x coordinates that are changing. The y coordinates stay the same. And the x coordinates change, but they do the opposite to what's in the bracket. So this says subtract 2, so everything's going to shift to the right 2. Normally, a negative 2 in a translation, for example, would mean we go left. But because it's a graph transformation, we're dealing with the x coordinate, we do the opposite. So everything's going to go right 2 places on the x-axis. So this coordinate here is currently at -2. If I move 2 places to the right, that coordinate is going to become 0, 0. So the y stays the same, it's the x that changes. Let's look at this coordinate then, guys. So we're at +2. If we go another 2 to the right, we're going to be at 4. The y coordinate stays the same. Let's look at this y-intercept here then. The x coordinate is 0. We're going to go across 2 places, so it's going to be level with this one, but we're still going to be at -1. So it's going to be at 2, -1. And then we're going to draw, as best as we can, our curve through those points. So that is that first transformation done. Okay, the next part. So the diagram below shows a sketch of y equals gx. On the same diagram, sketch y equals g negative x. Mark clearly any coordinates of intercepts with the axes. So we've got 2 points of intercept with the axes here. They're the coordinates that we're going to mark clearly. But what does y equals g of negative x means? This is a reflection, but it's a reflection in the y-axis. Okay, so this time it's a reflection in the y-axis. So the change is still happening to the x coordinate, but we're reflecting it across the y-axis. Now this point here, this point of intersection, is what we call invariant. It's not going to change. It's going to keep its position. Okay, guys, that's the important thing to remember. However, this point is going to flip across the x-axis, so it's going to mirror on this side. So instead of being at 5, 0, it's going to be at, let's pop it here, -5, 0. It's a reflection across the x. Okay, so we now need to draw that line. These are straight lines, so please use a ruler. Don't worry too much about the gradient of that line. Just make sure that it looks similar and that you've got that new coordinate. So remember, it's the x coordinate that's changing, but because it's a negative x, we're reflecting in the y-axis because we're changing the sign of the x coordinate. Question 23. The graph below shows a circle centred at the origin. So here's a graph of a circle with the centre at the origin. Part A, write down the equation of the circle shown on the graph above. So equation of the circle, with a centre at the origin, we start with x squared add y squared equals, and it equals the radius squared, guys, okay? So because it's the radius squared, we're going to look at our circle. So the radius is halfway. So it's from the centre of the circle, and we've been told the centre is the origin, to the circumference. So from 0 to 5, the radius is 5. So our equation of this circle is x squared plus y squared equals 5 squared. So x squared plus y squared equals 25. Part B, find the coordinates of the point of intersection of the tangent to the circle above at 0, 5 and the line y equals 2x plus 3. Okay, tangent to the circle at 0, 5. So the tangent to the circle, if I just draw that on roughly for you, that at the point 0, 5, it's going to be this tangent here. Now the equation of that line is y equals 5. It's a horizontal line through the y-axis. So the equation of the tangent to the circle is y equals 5. We want the point of intersection of this y equals 5 with this line y equals 2x plus 3. So they're both in terms of y. So to get the point of intersection, let's write them equal to each other and solve for x. So first thing we're going to do is we're going to subtract 3 from both sides. So 2x equals 2. And then we're going to divide by 2. Remember inverse operations. When we divide by 2, we get x equals 1. So we have our x coordinate as 1. We need to find our y coordinate. If we know x is 1, we can substitute it into this equation to find y. So y equals 2 times 1 because x is 1 plus 3. Well, y equals 2 times 1, which is 2. 2 plus 3 is 5. So our y coordinate is 5.